Implicit differentiation chapter, not too bad, and you will need it in calculus 1, 2, and 3, and in applications as well. It actually has a lot of applications, but usually students struggle a little bit, and I'm really good at explaining it, so let's take time on this and explain it really well. Then the name is weird, so it took me as a foreigner some time to understand what do they mean by implicit, explicit. So they say, what if, usually we give you the function like y equals 5x plus 3, and I said differentiate that. And like, no problem, y prime is 5. Yeah, what if y equals is not the case anymore? What if I don't even give you the writing which has y equals part? And you have to find y first. A, that's already a problem. And B, what if it's impossible to find it? So this is the example, y equals x to the 5 plus 5x plus 7, not a problem. Differentiate 5x to the 4 plus 5. We could do it so fast because y was given explicitly. Explicitly means it's there. Versus, here's a good example, x squared plus xy minus 7y cubed equals sine y plus 3x. Solve for y. Sometimes you can do it and it's long, so you don't want to do it. And sometimes you can't. You cannot do it here. Because of the y cubed y and sine y, it's officially impossible to solve it. You can always approximate it using computers, but it's not the exact solution, and I want to have exact solution. So that's what they call implicitly. Y is given implicitly. It's there, I see it, but I cannot use it to differentiate. So that's why the idea came in. What if we cannot solve for y? Then don't. Yeah, mathematicians are pretty lazy people. You can't, then don't do it. Don't find your y, f of x. Just differentiate implicitly, which means we're going to differentiate it like this. Like this. We just differentiate right away. And our job is to train you how to do it well and fast. I give steps. My students like it, I know that. Just for you to know, you don't have to follow those steps. That's not a theorem or something. That's the way I structure logically the information. And many people like it. They see the logic behind, they see steps. And when they stress out during the exam, they remember steps, they just still do well on the exam. So that's why I like this idea. Steps. Step 1, just like I said, we're going to differentiate everything right away. So let's find a derivative. Find the derivative. Find the derivative of both left-hand side LHS and right-hand side RHS. Very nice notation. Left-hand side and right-hand side. Differentiate both sides. Don't forget to do that. We saw people keep forgetting right-hand side. But when you do this, this is the list of mistakes. So I'm going to put notes. Every time you see y or dy by dx, the derivative is y prime. So let's do it this way. Every time you see y, or maybe you see dy of, f of x or y of x, doesn't matter. The derivative is y or dy over dx. I'm teaching with a short notation because it's faster to write, because I think on the exam you need to be fast. So, but you will see in the book and a lot they do dy over dx. That's a more proper way to show it. Just longer to write. Second one, every time you see x, every time you see x, the derivative of x, you will be shocked, but it is 1. Right now it looks a little bit dumb, but you will see what's the idea here. One function is independent, one variable is independent and the other one is dependent. So this is the most important point to point out right now. Y is a function of x. So based on the chain rule, So y of x. X is my input, y is my output. So x is literally inside of y, right? Y depends on x. X does not depend on anything. X can be whatever you want in a domain. Y depends on your input. So based on the chain rule steps in and says, well, if you're differentiating y of x, it's not 1 anymore. X prime is 1, but y prime, y of x prime is y prime. Looks weird, but I will show you what I mean here. And you'll get used to it at some point. Because x, just the input, derivative of that input x is 1. Y depends on x, so derivative of y is the speed of y. And that already depends on the input. Since it depends on the input, you should use chain rule. Chain rule says derivative of y is y prime. That's just the first step. The first step is the one that catches all the mistakes. Then it all goes well after this. When you have all those y primes everywhere, you know what to do? You take all the y primes and just push them somewhere else. It's exactly what you're supposed to do for the step 2. Just take them and push them. I prefer to do it on the left-hand side, but I saw people putting on the right-hand side. Whatever you prefer, your job is to collect them together and just move it. Yeah, I can do it for the best joke and then get the extra credit. So move parts. Step 2. Identify and move parts with y prime or dy over dx, whatever you wrote over there. Just be consistent, either or. To one side. I prefer left-hand side, but then I saw people doing right-hand side, so now I'm pointing this out. You don't have to do whatever I do. Whatever is convenient to you. Then other stuff, move to right-hand side, right, in my case. So important part is y prime. Other stuff, just move it away as well. And now you have y primes on one side and everything else on the other side. Step 3, factor out. Factor out this y prime dy over dx. Since now one side has all the y primes, you can factor it out. And then you will have this kind of picture. It will be dy over dx, factor out, parentheses, equals right-hand side. So this is how I do it. So you have that. You factor it out, there's going to be huge parentheses, some kind of stuff inside, equals right-hand side you moved before. Let's see. 4. Last one. Divide by this brackets. Divide by this part in bracket. Y, finally you will get the answer after this. You will get dy over dx equals right-hand side over those brackets. And that's the answer. It took me some time to explain the steps, but when you do the actual problem, it takes time as well. You will see on your exams, chain rule, fine, do this. Use implicit differentiation. That means it will take you 10 minutes. That's the one. I actually found a joke in the internet about that. There's 5 minutes left in the class and you found an implicit differentiation problem on a test. So yes, this is where you're supposed to be fast. Let me show you the example and hopefully we will learn to be fast at this. Example 1. Use implicit differentiation, and we usually say this phrase. To at least not to freak you out too much and to show you that it's not too bad. So use... No, okay, I will not write this down right now. On the test, we do write it down to make you feel better. But actually, you're supposed to figure it by yourself. We just ask you to find dy over dx. So just differentiate. Find y prime. If... And then we don't give you y. That's the whole point. Like y is not given. It's given as... If we know 3x squared plus 2x plus x times y equals 4 minus 40y. If we know this, and y at 4 is negative 13. Yeah. So the second part will be B. The first part is just to find derivative. Solution A. Find y prime first. And now I'm like, okay, if I have y equals, I will just do whatever. I know what to do, product rule, quotient rule, chain rule, whatever. But here, I need to find y first, and I don't want to. Technically speaking, I could. Do you see that? I could do it. I could just collect pieces with y, factor it out. I actually could find it in this example. But you don't have to. It skips the whole step. You don't have to solve. Implicit differentiation tells you, step 1, differentiate everything you see. Left-hand side and right-hand side. So everything I see in this box, let's differentiate that. Good. So let's do it. Derivative of the left-hand side. And now you see different things there. I see x and y. And that's the biggest problem of these problems. You're supposed to keep in mind which one is important and which one is not. So x is my input. Derivative of x is 1. 3x squared gives you 6x. Not a problem. Y is the problem. When you differentiate y, it's not just 1 anymore. So that will be an interesting case. You'll see what I mean here, but hold in mind that y is a dependent variable, x is independent. Derivative of 3x squared is 6x. I'm just differentiating, step 1. Left-hand side. Plus 2x gives me 2, not a problem. Plus x times y is a product rule. That's a new thing. X times y is a product rule. And I will put in little box, like a cheat sheet. X times y prime is, product rule says differentiate u, derivative of x is 1. Copy v, that's y, plus copy u, that's x, times derivative of y is, yeah, dy over dx or y prime. That's going to be the most common mistake people will do. They will put 1 here. But chain rule says not really, because y depends on x. Chain rule says y prime times 1. So y prime, because y is outside, times 1 because derivative of x is 1. If you put this in the box and look at it a couple times during your homework in the next week or 2, you will have less mistakes. And then at some point you'll learn it. But at the beginning, I would use this cheat sheet. So let's do it again for this case. X times y. Derivative of x is 1. Copy, I will write down, y. Derivative of x is 1. Copy y plus copy x. Derivative of y. Derivative of y is y prime. And this was a product rule. This was u prime v plus u v prime. So every time you see x, normal differentiation. Every time you see y, y prime should pop out. That's not the end. That's why my step says differentiate left-hand side and right-hand side. Many people feel happy to be done with left-hand side and forget the right-hand side. There's still right-hand side. What is derivative of 4? 0. What is derivative of negative 40y? Yes, negative 40 dy dx. Negative 40 y prime. Every time you see y and you're differentiating it, y prime should pop out. Or dy over dx. So negative 40 y prime. If you want to write down dy over dx, do that too. It's just longer. But actually it's better to write it down. Questions, what do you think? Derivative of negative 40x is negative 40. Derivative of negative 40y is negative 40y prime. That's the big difference. That was step 1. Questions, what do you think? Not too bad. But you have to practice a lot to make sure it's perfect. Step 2 says, identify all y primes and move them to the left. Everything else is garbage. Move it to the right. So that's what I do. I'm going to identify all my pieces with y prime. I will take a yellow color and I'm like, okay, that's way too thick. This is the piece with y prime. The whole piece will move to the left. I will move it to the left-hand side. This piece should be moved. Everything else, I don't like it. I will move it to the right. Y is not important either. Y primes are important. So xy prime is already on the left-hand side. I will keep it here. Now, negative 40y should be moved so it becomes positive 40y, not y prime. Make sense? I just added plus 40y prime plus 40y prime to the both sides. Equals. Everything else should be moved to the right-hand side. So 6x becomes negative 6x. 2 becomes negative 2. 1 times y becomes negative y. And this is how it should look like after you finish step 2. Y prime's pieces should be on the left. All other pieces should be on the right. Unless you like to do it mirrored, then just make sure they're all isolated on one side. Questions about this one? This is algebra, so I'm slowly just moving things around. Step 3, what did I say? I said, still identify y prime and factor them out. Now I'm identifying them here. Since now they are on one side, I can factor them out nicely, and it will look like this. Y prime, brackets, x plus 40. And don't touch right-hand side. It's there, standing, waiting for the right answer at the end. And the last step is students' favorite step. They sometimes merge 2 steps into one. What I want to do is to divide everything by those brackets. Whatever is on the right-hand side is the answer, because I will have y prime equals negative 6x minus 2 minus y all over brackets x plus 40. Let me check, and this looks good. Yes?
I did it instead of left-hand side, right-hand side. Now, pretty much it's the exact same answer, but the signs are different. Does that sound
That means you messed up probably over here. When you was moving things, maybe over here. Because when you move things, you need to be careful which one is positive and negative. Signs, oh, actually it might be correct.
Yeah.
If it's like 6x plus 2 plus y over minus x minus 40. Yeah.
Okay.
If you factor out the negative sign and it matches with my notation, it's good.
Yeah.
No, good question, yes. That's it, 4 steps. Not too bad. Why did we do that? Because it's your homework? No.
Yes.
Because you see this equation, this represents, I don't know, the trajectory of the shuttle going to the space. I'm asking you what's the speed of it, and you're like, oh, I know how to do it. I need to find y prime. How would you find y prime? If it's there mixed up with all those functions and equations, you do implicit differentiation. And when you see it in the book, you not freak out anymore. You see, oh, they did implicit differentiation. That's how they did it. That's how they found it. I found y prime. This is only A, we still need to do B, but I have a question right now. What's the difference? Interesting, there's something different. There's something different supposed to bother you a little bit if you paid attention. We usually have y prime equals stuff. Now we have y prime equals stuff, and they look different than what used to be. What's the difference? What do you think? Yes? There's a y in there. Do you see? Did we have this before? We didn't. There's a y in the answer. That's new. Usually we have y prime equals 30x plus 5. And then I give you input, x 10 cups, sell 10 cups. Your y prime is how much faster your profit is increasing. Here you have x and y. Indeed, the only new thing with implicit differentiation that since you could not solve for y will be in the answer. That's not good or bad, it's just a fact. That's how just it happens. But it's unusual. Not only input but output are in the answer of the derivative. That's a very interesting idea. Here, that's why B, let's go to the question. The original question actually asked us, find dy dx at the original point. What point? Y at 4 is negative 13. So, find at y. No, we know like this. We know y at 4 is negative 13. We know that. Find y prime. Okay, that's why I gave you those two. It was not like find when x is 7. Okay, if I give you x equals 4, for example. X equals 4, that's not enough anymore. I will plug x equals 4 here, and then y is still there. That's why we have to give you both. From now on, if we're working with implicit differentiation, I have to give you both, x and y, if I want to ask for y prime at the point. Make sense? So I gave you x and y. This notation means when x is 4, y is negative 13. Let's plug it in. Y prime will be negative 6 times 4 minus 2 minus negative 13 all over 4 plus 40, which becomes 44, and the top is negative 13. Check. 44. That's what my notes say. And that's the answer. Derivative at the point. This B thing is not very common. We don't really ask you to do it often, but I wanted to show you that now we need to have x and y. That's like a different new thing here. What do you think about this? Yes, not too bad. This is long. Those problems are usually long, and the more you do it, the faster you become. So let me start one more, and then you can finish at home. What if you have, so find y prime if, and I have 5x minus y to the 4 plus 4y cubed equals 1300. This is a good example because I saw many mistakes with this 1300 piece. So I will show you what's the problem. Okay, first of all, I cannot solve for y to find y prime. All the knowledge of the chain rule, product rule, and quotient rule do not work right now, unless you know implicit differentiation. So step 1 says, it's fine, you don't have function given explicitly, then let's differentiate implicitly. Step 1, find derivative of the left-hand side and the right-hand side. What is derivative? 5x minus y to the 4. Chain rule. 4 goes down, change the exponent. Right? What's inside? 5x minus y. Don't touch it. Copy it. So remember this. Copy. That's what chain rule says. Now you can touch it. Now chain rule says, wait, don't move on. First look at inside and differentiate that. I'll look at 5x minus y. And derivative of 5x minus y is, what do you think? Oh, you're actually very good at this. I'm saying that because usually at the beginning, people are not good at this. So, like, good job. If you got it, it's really good. 5x gives you 5. We know that. Y is not 1. Y, when you differentiate, becomes y prime. Or dy over dx, if you want. So that's the first piece. Plus, I know it's going to be 12 y squared. Is that it, though? Every time you see something that includes y prime should pop out like this, based on the chain rule. Because basically you have something raised to the third power. 3 goes down, multiplied by 4 is 12. This is something squared, and then times the derivative of the function inside. Function inside is y. Derivative of y is y prime. Or basically remember, every time you're working with y prime should pop out somewhere. If it did not, you lost it. Equals 1300 or not? 0. And that's the most common mistake. You get happy to be over with this on the exam, and then you copy 1300. Differentiate the right-hand side, and derivative of the right-hand side is 0. Step 2, what Patrick said. Find all the y prime and move them to one side. Not very obvious here, because y prime here is kind of factored. So I want to distribute it first. First, simplify. Simplify, or basically distribute. Distribute y prime. Because how can I move y prime to the left-hand side if it's 5 minus y prime times something else? So what I'm going to do, I'm going to slowly and carefully distribute 4 5x minus y cubed times 5. That's the first piece. Minus. And now that's the important piece. I'll put it in blue. 4 5x minus y cubed times y prime. That's the piece I need. That's why I wanted to distribute. This piece is good. 12y squared times y prime. And the right hand side is just 0. Now I can take yellow color, and I do recommend you to use colors, the red color, whatever, and then put a note for yourself. This is what I need And this is what I need to be on the left with a negative sign over here. Everything else should be moved. So that's my step 2. It's right on the left-hand side, so just keep it there. Negative 4, 5x minus y cubed y prime plus 12 y squared times y prime. That's pieces that have y prime multiplied by them. Make sense? Why I need that? Because I want to factor it out later. And then whatever was without y prime, I move it to the right, so it's going to be negative 4 5x minus y cubed times 5. Okay, that's a little bit downward. We're having 4 times 5 separately, right? It's supposed to be negative 20, but I will do it later. Step 3, I'm going to circle y prime and factor it out. That's the whole point why we're moving it. So I will have y prime brackets negative 4 5x minus y cubed plus 12 y squared equals right-hand side. Let me do it, negative 20 5x minus y cubed. The last step, students like to skip it and they just write it like this. The answer will be over those brackets. And then they tell me this is the answer on the right-hand side. But I will be nice and write it down. Y prime equals right-hand side negative 20 5x minus y over cube all over negative 4 5x minus y cube plus 12y squared. And this is the final answer. Implicit differentiation takes 4 steps, and there's 2-3 steps, and in each you can make a mistake. How you differentiate, cause mistakes, how you move things left and right, that's algebra, how you factor out, checks your factoring abilities. I did show it in the lecture 0, because I know we're going to be using it. And the last one, usually nobody does a mistake at the end. You just divide by the brackets.